This is the fourth mini lecture for section 14.1. Yeah, we have one last thing to discuss, which is complementary events. So if E is an event in the sample space S, then the complementary event, E bar, notice there's a little bar over the E there. That's the complementary event. The complementary set, E bar, is the complementary event. So remember, back when we first learned about sets, we learned that if you have a set E in a larger universe, then everything outside of E is the complement of E. Okay, we're using terminology of sets quite a bit here, so if it's been a while since you've seen that, or you're not too confident about it, now would be a good time to review that material. So if E is an event, then the complementary event is the event in which it doesn't happen. So if E is the event in which it rains, then the complement is the event in which it doesn't rain. And because the two events make up the whole sample space, but on the other hand they don't overlap, the probability of one or the other happening is always going to be 100%. Right? What's the probability that it will rain or it won't rain? Well, 100%. If I toss a coin, what's the probability that I'm going to get a heads or a tails? 100%. So, when you talk about the event and its complement, you're talking about everything altogether. So the probability is going to add up to 100%. So that means that the probability of something happening is 100% minus the probability of it's not happening. Or in terms of ratios or fractions or decimals, it would be 1 minus the probability that it doesn't happen. If there's a 40% chance of rain, that means there's a 60% chance that it won't rain. And oftentimes, it is easier to compute the probability that something will not happen than to compute the probability that it will happen. So for example, what's the probability of getting at least one head on a single toss of 5 coins? So there's two ways of going about this. First of all, no matter what, we're going to have to figure out how many different outcomes there are. And we'll talk about this in more detail when we discuss the exercises. But we're tossing 5 coins. You could just think about tossing them 1, 2, 3, 4, 5. Each coin could be heads or tails. So the total number of outcomes is going to be 2 times 2 times 2 times 2 times 2, which is 32. That's how many possible outcomes there are. Okay. And this reasoning comes from drawing tree diagrams, which when we talk about the exercises, we'll draw some of those, and that'll be a bit clearer perhaps. But now I want to know what's the probability of getting at least one heads up. At least one heads up when we toss 5 coins. So I could do this by trying to add up all the different 32 outcomes that give me one heads up. But it's easier to figure out how many ways there are to get to not get this, to get less than one heads up. The probability of getting at least one head, the complement of that would be the probability of getting no heads at all. So the probability of getting a tails, 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 that's 1 out of 32. And so the probability of getting at least one heads is 1 minus 1 out of 32, which is 31 out of 32. And so you see that's a lot easier than trying to count all the different ways I could get at least one heads. You know, heads, 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 tails, heads, heads, tails, heads, sorry, heads, 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 tails, heads, 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 tails, heads, heads, you know, so on and so forth, right? That's going to take a while to list them all and be easy to miss stuff. But it turns out that it's easy to figure out how likely you are for that not to happen, because there's only one way for it not to happen. So if you get 5 tails, and so since the probability of that is 1 out of 32, the probability of getting at least one heads up is 31 out of 32. Okay, so I think you will find the exercises in this unit rather challenging, and we usually spend a lot of time in class talking about that. So we'll be doing quite a few of these during our class meetings together.